Look at the vast expanse of Lake Victoria. Imagine a fisherman navigating these deep waters at night, far away from land. Out on the open water, there are no road signs, no taxi parks, and no trees to guide the way. Getting from the Casenzero landing site to the Sese Islands in the pitch black requires a precise mathematical language. This diagram illustrates that language: bearings. To translate physical space into exact numbers, bearings follow 3 strict rules. First, always start measuring from north. Second, always measure clockwise. And third, always write the answer using 3 digits. These rules ensure navigators can chart a reliable course when the physical world provides 0 reference points. This map shows the layout of Uganda. If we need to find the exact bearing of Jinja from Kampala, we start with the most important word, from. It tells you exactly where to stand. Because we measure from Kampala, it is our anchor. Following the first rule, we draw a true north vertical line from this anchor point, then use a protractor to measure clockwise to the path leading to Jinja. Getting the anchor point wrong invalidates the entire measurement. If you place your protractor on the destination instead of the starting point, the resulting angle will lead you miles off course. This diagram illustrates a new scenario: a ship leaving Port Bell, sailing towards an island directly to its left, in the west. Because the target is on the left, the natural instinct is to measure the shorter, anti-clockwise distance. But our second rule is absolute: all measurements must sweep clockwise. We measure all the way around the circle to find a reflex angle of 270 degrees. To accurately map this 40-kilometer journey onto a small piece of paper, we use a scale drawing. With a ratio where 1 centimeter equals 10 kilometers, we divide 40 by 10 to get exactly 4 centimeters. We align a ruler on that 270-degree bearing and draw a line exactly 4 centimeters long to represent the ship's path. Combining strict mathematical angles with a precise scale ratio shrinks real-life geography to an exact model. The journey continues. From this island, the ship must now sail 30 kilometers on a bearing of 180 degrees. Before we can use the protractor to calculate this next leg, what crucial line must we draw first? We must establish a completely fresh north line. Every time a journey changes direction at a new waypoint, a new north anchor is required. Aligning the protractor with this new north line, we measure 180 degrees straight down. Applying our scale, the 30-kilometer distance becomes a 3-centimeter line drawn to the final destination. Any complex journey is just a chain of single bearings, linked together by fresh north lines. Notice how the final destination and starting point form an open triangle on our map. If we measure that gap, the ruler shows exactly 5 centimeters. Multiplying that back through our scale ratio, we determine the actual physical distance is 50 kilometers. We calculated the exact length of the return trip without having to travel it. This predictive power allows surveyors and pilots to map routes long before they ever depart. This graphic summarizes the 5 key pillars of navigation. Locate your exact anchor point using the word from. Start at north. Measure clockwise. Use 3 digits. And at every new waypoint, draw a new north line. Mathematical precision removes the guesswork from travel, ensuring you can plot your course and find your exact destination anywhere on the globe.